name is Sean. Basically, I'm from it. First of all, thanks for the Pen Water Chapter for organizing this event. Especially thank to AR, Patricia, and Edna for the introductions. So, and also give applause to yourself. Thanks for your dedication, your effort as well. I mean, coming on the weekend, early morning, and some more I heard some they are traveling from Taipei, from Alostar, where you need to drive for 2 hours. So give applause to yourself. Thanks for your dedication. So basically, I have only 1 hour, and actually I have quite a lot of things to cover. But no worries, they are quite they are not tech savvy. Basically, I mean most of them are like photos, reference, and so on. But we are too excited, and we are quite a lot of agenda topics, application to cover over. So I will make my presentation slightly faster. So please bear with me. So my name is Sean. Basically, I'm the technical sales for Southeast Asia region. And the agenda for today, just a very quick introduction about who is text, who is format. I mean, I take the opportunity to clarify a bit because there has been some confusion, like actually who is who and what was going on. And of course, later on, we touch a bit on the basic of the fire, just to have a more understanding on the fire principle. And of course, later on, some of the solution-based when it comes to fire protection. Of course, later on, we have a separate Q&A. A quick one, on the nutshell for eText, basically eText is the company name, is the entity, whereas Format is our branding. So we are a Belgium-based company where we have office in Malaysia and a strategic partner in Klang, where they are running the fire test laboratory. So just some of the overview where we have about 15,000 employees operating in 45 countries with more than 160 manufacturing plant facility worldwide, globally, and we have 7 R&D centers with 3.8 billion turnover last year. And when it comes to format, basically we are reliable partners when it comes to the passive fire protection. We just focus in passive. So we believe we have the most comprehensive portfolio when it comes to passive fire protection in building construction. So this is some of the solutions that we can cover when it comes for building construction, starting from the structural, whether it's steel, timber, concrete. Then come to the compartmentation where you want to divide it a large area into a smaller area, fire-rated partition, fire ceiling, even a fire-rated flooring, and some of the barriers to the fire stopping, where those services passing through the compartmentation. So when there are services like cable, piping, ducting, passing through the firewall or fire floor, basically they give a big point. There's a gap that opening where we need to fire stop it, and of course MEP, where those critical services that need to remain functionality when there's a fire, like smoke extraction duct, pressurization duct, and so on. And of course, fire regulation and tunnel. So, what is all of this about? Basically, about the life savings, about to protect the people, to protect property, to protect the asset, and also to make sure the business continuity, minimize the damage recovery. So this is the main purpose for the fire protection. And so I will spend a bit touching on that. It actually, you need a balanced approach, a balanced strategy when we design for fire protection. Neither active or passive, they are good enough by itself for the fire protection strategy. It always is a balanced approach where you need to use the active and passive. So active is those like where you need something to trigger, like for example, the alarm, smoke, fire, leaky sensor, where you trigger, then there's a reaction, there's a response come in. So like sprinkler, alarm, extinguisher, fire suppression, they are all classified as the active fire protection, whereas passive is something is a built-in element. Once built, you will just sitting there silently working 24/7. So when there's a fire happen, the role of passive is to condemn, to control the fire size that's being spread to the next door, to the next room, next compartment, whereas active is the one that to suppress the fire and ultimately to put off the fire. Of course, today my sharing will be more passive. We talk about how all these solutions can integrate into your building design. But before we go into the details, first some of the theory about the fire, reaction to fire and resistance to fire. They sound quite similar, but somehow the meaning is quite big different. Reaction to fire, we talk about how the material to react when it contact the fire, whether it burns, whether there's no reaction, or whether it will generate no smoke. All talk about a single material, a product approach. Whereas when it comes to resistance to fire, which is on your right side, we talk about how a complete assembly, a system, how it limits the spread of fire and the smoke. So there are few criteria that we will measure for the testing. So first of all, the far top about wood bearing capacity, or sometimes we call stability, or sometimes noted as an R, is to measure how the stability of a system. So as such, let's say 2 hours, within these 2 hours, this system, let's say a column, a beam, a floor, it should be intact, it shouldn't be collapsed. If any failure, sagging, deflection more than certain limit, we consider a failure. Collapse, consider a failure. So all about the structural integrity. Whereas the second criteria that we will measure, integrity, or noted as an E, we measure the behavior, the pattern on the known fire site. So the past criteria is basically, if let's say next door there's a fire, so over here with this firewall, it shouldn't have any passage of fire and smoke. So it shouldn't have any crack, opening, and so on. And something that invisible, that we cannot be seen, which is the heat. There's a fire. So when actual building fire, the temperature easily more than 1000 degrees Celsius. So standing next door without a proper firewall, you will become a barbecue. So there's another criteria where we will measure, which is insulation. So noted as I, basically is measure how the heat transfer, how well this system, this assembly can block the heat when there's a fire. So the criteria is 140 degrees Celsius average temperature and 180 maximum temperature on the known fire site. So this is just some of the comparison between the reaction to fire testing and also for the resistance to fire testing. So normally on product based, the testing, the scale is smaller, normally in the lab, where on the left is the known capacity test, whether we fall on BS 476 part 4 or with the ISO 182, it all tests about known capacity test. So basically it's the top ceiling for the product performance. Then for the resistance, then the temperature maximum 750 degrees Celsius for the furnace temperature. Whereas for the resistance to fire, normally the scale is much more bigger. So most of the time we need to represent the actual construction. So the furnace also much bigger, whereas 3x3, 4x5, 5x5, or even 5x7 meter. So, and the criteria would be the barrier, integrity, and insulation. These are the criteria that we will measure when there's a fire test, depending what kind of application, and in terms of the fire curve. So, there are quite a few. The red line, which is the standard time temperature curve, or sometimes we refer as ISO 834 curve, which is widely adopted in BS and this kind of standard, basically is for the building fire. So at 1 hour, it's about 950 degrees Celsius, and 2 hours, slightly more than 1000 degrees Celsius. So this is the fire curve where we widely adopt for building fire. So depending on your purpose, your building group, so others fire curve can be applied as well. For example, when there are more petrochemical industry, then we use hydrocarbon. Even hydrocarbon, there are two. So one is based on the UL where it is more intense. At first 5 minutes, you need to reach 1200 degrees Celsius, 1200, and then maintain for the remaining hours. But of course, there are others like for tunnel, for train, for facade, and so on. So this is just some of the reference, like how fire test looks like. So there are different applications. So on the top left, basically is a vertical testing where we test it, let's say, for partition. Then the second, horizontal. Second and third works very similar. It's a horizontal elements, like for ceiling and floor. But on the third one, you can see there are hydraulic jet above. This is where you need to apply the loop when there's a fire test. So making the testing more onerous. So the testing for ceiling and for flooring, they are different because floor is meant to take the loop. Of course, for beam, columns, ducting, each different application, the criteria is different, the test method is different, and the test is different as well. So same to fire stopping. Fire stopping is even more complicated depending what kind of services, what kind of penetration, whether it's metal pipe, plastic pipe, cable, what kind of cable, what kind of plastic, whether it's PVC, PP, and so on, or you need to test individually. They are all different tests. So after all this, basically what we want to emphasize is product, reaction to fire, and a system approach to system to fire. They are different. So for reaction to fire, basically it didn't come with a duration, it didn't come with a time. So there's no, I don't normally we go with, let's say, I need a 2 hours fire material, let's say 2 hours fire board, 2 hours fire paint, so on. But it should come as a system. It's a full design, it's a full assembly, it's a system approach where the design, every component, it contribute to the fire performance. Like for example, over here, it's just a ducting, but it's not only the duct itself, it's not only the board itself, even the framing, the screw, the spacing, and so on, it all contribute for the overall performance. So a good example, the wood is a flammable material, but through a proper design, it can be the timber fire door that it lasts for, let's say, 1 hour or 2 hours. It's a system, it's a design. So why versa? A non-combustible material, yeah, it doesn't contribute to the fire load by itself, it has no response to fire, but without a proper design, it could be compromised. For example, the board crack, it collapse, the fire still can pass through. So we now come to the core of my sharing today. Start with structures, for the structurals. So we know that all material can be exposed to high temperature, elevated temperature. The strength of the material will gradually decrease, it will lose the strength, and when it reaches the limit, then it will collapse. So this is just an example of steel. At about 550 degrees Celsius, the strength only left about 60%. So this is the benchmark when we come to the structural steel design. Critical temperature, 450 degrees Celsius for the column, and 600 degrees Celsius for the beam. So this is the principle behind. If let's say we come across structural steel, why there are 550, why there are 600, of course, things is more complicated than this. This is just a sharing on the case study where it happened in Madrid, in Spain. Happened in the year of 2005. the building was first built in 1979, where at the time the fire code was not so developed yet. So in the year of 2005, they decided to have an upgrade where they introduced sprinklers, they introduced the fire door, they collect the hollow section, the structural protection, and also they give the external staircase. But somehow, halfway of the upgrade or renovation, it caught fire. So basically what you see is a complete mega structure, the core structures, where the parameters with the steel structures. So I think somewhere around level 20 above, where at the time we didn't manage to make the installation for structural protection. So the steel cannot survive and there's a fire. So on the right photo, where what you see, the red color column that has been badly distorted is the hollow section that without a proper structural protection, whereas the white color above is the hollow section that collided with the fire protective board. So then you can see the big difference with and without the protection after fire. So when it comes to structural steel protection, there are various protection methods. So whether for vertical spray, whether with the board encasement, whether with the immersive coating. So depend the criteria, depend the preference, what you need to achieve. So this is a quick comparison between the three. So basically for board encasement and vertical, the fire rating is up to 4 hours, whereas for immersive paint is only up to 3 hours. So this is quite general across the market players. So for molecular spray and immersive paint, basically they are considered as the wet works. So when they carry out the application and installation, the site need to be isolated. So other threads that cannot ongoing together. So they need to do the masking, they need to barricade this area for them to carry out the installation. Whereas for the board encasement, basically it's a dry thread. The board is produced at the factory, it comes with the uniform thickness, and it requires less skillful installation team, where the board just cut, flat, fixed to the structurals. So, but for spray and paint, you need a skillful worker, and you need to consistent QC check during the application, because you need to achieve certain thickness. If let's say a less skillful worker, then the appearance, the workmanship might be compromised, it might become wavy, inconsistent thickness, and so on. But of course, spray being the most economical options, it is very preferred when go for a larger area. But also where the aesthetic is not so concerned, because the surface, the texture is rough for the regular spray. So if you aesthetic is a concern, space is a concern, then immersive paint is the preferred option. It's very thin for 2 hours. The bed of stool size is ranging around 1 mm to 3 mm. So whereas your spray and board can be easily 20 to 30 mm. So it's a big difference. And for paint, it can be used for outdoor as well, but provided there is a top coat. Then for board, you can receive any kind of architectural finishing on top. So I will show some example later on. This is just a quick reference between the three, from board to spray to the paint. So on the left, basically it looks like a timber, but actually it's a steel structures with the board encasement and the timber finishing on top. So for the paint, where you want to maintain the steel look, the architectural look, in nice, aesthetic, then paint is the preferred option. Whereas for spray from far, it looks like quite smooth, but if close up, actually it's quite rough and quite nasty as well. On the video, it basically shows how the immersion react when there's a fire, when there's a high temperature, when it's exposed to the heat. So the same apply not only for the indoor heat, but also apply to the fiber material. It basically to show you how the indoor expand. So the max you can expand about 50 times. Let's say 1 mm, you can expand up to 50 mm. So the top photo is just some demonstrations. I mean, it's not a proper test, it's just to demonstrate. Like there's a paint on the base metal, when you expose the heat, the torch, it expands. So it's the working principle for the indoor paint. Why the paint is so thin, but it can provide the same rating as other protection method. So from here also, it explains why when it comes to intermotion paint, you need to leave some certain gap for the expansion. In the real application, if there is something attached to a steel that being treated with paint, it basically the purpose, because the paint needs the space for expansion. So one of the benefit of having the intermotion paint is it can be applied off-site, meaning that it can be pre-painted at the fabrication yard, and then later on the steel being brought to the site for erection, which speed up the project timeline. This where other spray and board cannot be done. So some of the reference where the beam, the column being treated with the intermotion paint, and this is a very good example of showing the purpose of the intermotion paint. So it's a project in Singapore where the tree branch is actually made from a customized circular hollow section where they want to represent the tree branch. It's a primary structure that holding the roof structure, but at the same time we want to maintain some architectural look. So another advantage of having paint is it can be applied on the complex structures or hard to reach area. Then also it can be done for the outdoor application, but you will require a PU coat on top for the weather resistant. So for the molecular spray, basically apply on a large area. So this is the bond deck with the roof truss. So some of the column and beams with the molecular spray, where mostly being used in the let's say industrial building, and also some of the commercial building where aesthetic is not typical. So where for the commercial building, normally they will have a false ceiling and also an ID box up to cover up on the molecular spray. So these like for example the Tokana, and for commercial building, but later on they will have a false ceiling and ID box up. But over here you can see that actually the surface, the texture of the molecular spray actually is quite rough. It's not as smooth as like board or the intermotion paint. So this is another reference for the board encasement that I shared just now. It looks like timber, actually it's a steel structures with the board encasement and the architectural finishing on top of it. So this is the advantage, the benefit of having the board encasement, where it can be also camouflage or to blend seamlessly with the edges, let's say the partition or the ceiling. So the pillar or the beam can be hidden high. So for this actually is what to explain the benefit of using board encasement. Actually this is a roof truss where this is already cladded with the board encasement, and on top of that you can see that still haven't treated yet, and there is this firewall underneath. So actually this firewall is coincide, is meeting at the roof truss. If you're using paint, you're using spray, so the opening between the roof truss, fire still can pass through. Although you have a nice firewall underneath, but there's opening above, so fire still can pass through. So this is where another advantage of using the board encasement. So you can maintain the compartmentation. So even some of the complex shape, it can be done with the board encasement, and also when there is some partition or ceiling that are being attached to the structurals before encasement, it can be done as well. Whereas for the spray, then you need the ID box up, there's a gap, so the structure might not be rigid enough. And also, if there is paint, if the structure is directly attached, it also affects the purpose. And the last is basically the whole encasement can work together with the partition, being led into a same system, same approach. So when it comes to structural steel protection, normally there are quite a lot of questions that you ask, because structural steel is not as straightforward as what you have tested that you can apply. So there are a lot of consideration, whether what is your fire rating from 1 hour to 4 hours, and then later on what kind of protection method. This will affect all the calculation. For board encasement, basically just a square or rectangle. The area that is exposed to fire is relatively lesser compared to the profile type where you have spray or you have paint, where follow the contour, the profile of the steel. The exposed area will be much larger. Then also the exposure. Normally column 4 side, beam 3 side, but certain design it could be 2 side or even sometimes for strengthening only 1 side. So all these will affect the protection method, the protection thickness, and of course differentiate whether it's IH, whether it's SSH, RHH, or even CHS, or maybe you have plates, and so on. So of course outdoor or indoor, then these are all the key consideration that we need to consider when it comes to the steel. So I just add in this animation, basically just to explain the rule of thumb when it comes to a structural steel. So for a thinner profile compared to a larger profile, a big steel, what is the difference when it comes to the protection? So a bigger steel, basically you have more metal, you have higher thermal mass. So it also more tolerant to the heat, it can absorb more heat. Whereas a thin profile, let's say like vintage of a steel profile is very thin. When you expose to a high temperature, it can be easily distorted, it can easily compromise. So in this case, then we will need more protection thickness for that. So general rule of thumb, for big steel, the protection thickness will be thinner. For smaller steel, the protection thickness will be more bulkier. So we come to the compartmentation, basically where you have a big area and then you want to subdivide it into a smaller area in order to control for the fire. So they are vertical, there's horizontal, and even sometimes you have a cavity barrier where you have a roll shutter or a door that above there's a cavity where you want to fire stop and fire seal. So when it comes to vertical compartmentation is also a field design. So the most conventional, I think, quite familiar with everyone in a steel stud partition, where you have a framing, whether infill with block wool, and then without the mineral wool, then both sides will fix with the fire protective board. So normally it's a symmetrical design, tested up to 4 hours. Then there's a mineral wool in between, whether it's the first design for fire or later on for thermal and acoustic comfort. So there's also another design for the solid partition or slim partition, where there is no mineral wool. Also tested 2 hours and up to 4 hours. And in terms of the overall thickness of the partition is much thinner, much slimmer compared to the steel stud partition, which is more general common type. So another advantage of solid partition is also it can be exposed from one side. It's a symmetrical design, 2 layer or 3 layer of boards, then it can achieve 2 hours up to 4 hours. Then of course the other one is more heavy duty, more rigid, robust kind of system, where it can even cater for blast resistance as well, blast and fire together. So in general, steel stud partition where you have start, infill, and protected by the board. So this basically is for the heavy duty type of the use. So this actually is for the underground subway. Like you need to maintain the supply of power for the fire suppression or for emergency use. So, and why it need to be done to have the fire accommodation, and also because when fire tanker cannot be used. For example, for the kitchen duct. So for kitchen duct, basically during cooking, during the normal daily use, there's a lot of grease, there's a lot of carbon, it will be inside. And also due to the heat, you might have a force trigger. Due to the heat, about 100 degrees Celsius, for example, it might trigger the fusibility, then it might trigger the damper, or the grease, the carbon deposit, it might affect the functionality of the damper. So in this kind of case where fire damper cannot be used, the duct line, the ducting need to be compartment as well. So there are a few reflection methods, basically where collected to steel duct, meaning that the GI duct is already up, is already erected, and I found out that actually I need to fire treated, I need to fire compartment this duct line. So there's a solution where we plug onto the steel duct, and also tested up to 4 hours. Then another normally involved in the early stage where you already know for this area I need to have a fire duct. So it can be fabricated with the board without any GI duct inside. So the last, on the right option is when there's a duct, I need to upgrade it, I paint it, but I need to add a room on top of it. So reason why, because they need to achieve stability, integrity, and also insulation when it comes to the ducting. So on the right, basically just to show some installation sequence where you have the GI duct, you put some framing on top of it, put in some infill, and later on you clad with the fire protective board. So some of the reference, what it looks like, we come to a solution, and generally the board itself, the hardware solution also relatively more durable. So this is a project being first constructed in 1990, and the photo was taken last year. You can see that the duct with the board basically still quite new, still quite durable. And of course, depending on certain area where you need to improve the further security. So this was also a project where we used for KL. Is initially already pre-painted, already achieved the fire security, the fire safety, but somehow the client want to improve the security because the client feel like a thin 1.2 mm of a GI sheet can easily break in. So this where they use a heavy duty to further improve, to enhance the burning proof. And as a reference, where the duct fabricate just with the fire protective board without GI duct. So some example of different design of the fire duct as well. So other than the board solution, it can be painted or it can be sprayed as well. Both also achieve stability, integrity, and insulation. They have the same fire performance, just like a different protection method. And basically also same to the cable, other than the ventilation duct, but also for the cable duct. So where you want to maintain the safety integrity of the cables, meaning that throughout the internet period, for example, 2 hours, within this period, the power supply cannot be interrupted. So any interruption, it will cause the failure because power in this case is very critical. That's why there's an additional measure for the circuit integrity. So like protecting the backbone of the power. So the whole power line is being fire compartment. It's a fire stop. So like for example, some of the reference where the high voltage cable, the incoming cable is being fire compartment. So in this case, it is for fiber optic. So basically,
Sorry, I forgot about you. Yes,
not only
26.
simplicity as I mentioned
Yes.
earlier,
We'll be the same
I'm
again.
going to show you how
MC, is it
practical
okay?
our solution is,
Can.
or
I check
how
with Korea first.
practical
She
and
okay?
efficient
She okay? Yeah.
BricsCAD
Thanks.
is. So who are we actually? Most people know about BricsCAD. Some people doesn't know about BricsCAD. So I'm going to show you a transition, a progression where we are. I know this is a little bit interesting. So Bricsys is our company name. BricsCAD is our product name. Okay, we are founded by in 2002 by an architect with the mind to provide fair and efficient CAD to the world. And of course, he has a hidden agenda against the big great logo. We are again similar to Promet. Our HQ, global HQ is actually in Belgium. So our software is built on a native DWG platform. So whatever DWG drawings you have, DWG templates you have, line types you have can be easily migrated over to our application itself. There are 3 F, as I mentioned here, that I will be sharing consistently to the team. Familiarity, fidelity, and flow. Most CAD tools give you feature, but what I want you to take away is BricsCAD gives you the flow without disrupting what you already know in the DWG workflow on a day-to-day basis. And of course, in 2015, we developed our BIM application. Okay, so we're in the business for more than 22 years accounting, and in 2018, we got acquired by Hexagon. Not Hexagon Construction, but Hexagon AB, a Sweden company stationed in Stockholm. Again, we are part of that, which is a multi-billion-dollar company. We are here to stay. And in 2019, of course, unique workflow comes up, scan to BIM. What it means is, Hexagon is well known for surveying, Leica surveying, point clouds. If you understand about point clouds, you can actually bring in the points cloud into BricsCAD directly without a third-party software. And we are proud to say we can handle up to 99% of all point clouds format. If you notice this, hang on. This is actually to highlight that the Singapore government actually give us a thumbs up in terms of credibility and productivity by warranting our name to be part of their productivity grant to the SME for the built environment, which means that when they buy their software through that particular government portal, the grant is up to 50%. I hope the government can do it, but anyway, don't worry, we have fair pricing as well. Again, from a part of Hexagon, only recently in March this year, we are being spun off into this company called Octave. Now, Octave is still part of Hexagon. What they did is they consolidated 4 software business units in Hexagon and formed Octave. We are still called BricsCAD, or lovingly right now called Octave BricsCAD. Okay, so you will learn a lot more on what Octave actually is. So this is our logo. It connects construction right now and operation into one life cycle. What we're going to present is 4 pillars, and these 4 pillars are going to interconnect right down to build environment and even protect environment in the cybersecurity space. So what it consists is design, build, operate, and protect. The goal is not more software. Okay, even though we have 4 pillars of software right now, the goal is actually connected decision. Okay, architects usually focus on design, but your model doesn't stop at the design. It lives through the construction and operation phase. And where Octave is, it connects the entire journey itself. What we offer, okay, where BricsCAD or Octave BricsCAD is playing. So we are still in the design pillar phase, but what is critical is the handover from design to build.
what we help architects like yourself is to improve your design, make it practical, make it accurate, and when you do hand over, right down to construction document, it is buildable. Okay, it makes sense. There's no rework, it is on time. So this, it's a complicated design chart, but just bear in mind that this is the critical stage that you need to take note. Okay, and this is where you start using BricsCAD from the design, conceptual right down to design. We accept and we can import in SketchUp if you want to, just for your info if you're using SketchUp as well. So let me go on with this. Octave. Everything we build boils down to three things that you need to take away from this slide. So basically, simplicity, okay? Simple to use, open to integrate, and as well as smart enough to save you time in how you churn out your design and right down to your construction documentation itself. So I was at the booth. We have a booth behind. A lot of questions was being asked. Kelvin, how is your pricing like? Okay. Actually, I know this is very important. I would say that we offer a fair pricing. As those that earlier watched our video, we have perpetual and subscription license itself. Okay, but open your mind and stay tuned on how BricsCAD can value add to your existing organization and workflow without disruption. And then we talk about fair pricing later on. Fair enough? Fair pricing. Okay, quick dive into BricsCAD. One of the things that I want to share with you is our productivity tools. This is our unique selling positioning, where I think if I dare to put forth AutoCAD LT and AutoCAD don't have it. So what exactly is our productivity tools, which I will actually dabble into. But before that, remember what I mentioned, familiarity. So those that are AutoCAD users, can you spot the difference? This is the blue team, I think Chelsea soccer, if those you know. This is the red team, Manchester. Okay, but those are no soccer, I'm sorry. Very familiar. Remember, BricsCAD is not a clone. We start refactoring our software since 2006, which means that till date, the foundation of our source code is solely owned by Bricsys itself, which means we are not afraid of being sued by Autodesk or anybody. Oops, did I say Autodesk? Yes, I did. Okay, so there is bound to be a difference, and what are the differences? One of the key differences is the productivity tabs. So we are going to quick dive into the productivity tools that we have. So, Kelvin, what is productivity tools? So you can read here as I speak. So most CAD users spend time repeating your task. Traditional CAD command will take perhaps 10 to 27 steps to complete, perhaps. But with our productivity tools, you shorten and accelerate the task completion. Okay, what I'm going to show you next after this is actually a quick video animation on one of our productivity tools called Move Guided. Okay. Oops. All right. So as promised, Move Guided is actually one of our productivity tools. We have the traditional command called Move, Control M. Okay. This video is going to show you how we are going to use our productivity tools instead of the Control M to move one door from a wall to another side of the wall. Simple. It is not a complicated task, but in a traditional CAD command, it takes you more than 20 clicks. You need to create reference line, you need to move, you need to rotate, you need to add, you need to subtract, you need to heal. Okay, etc. etc. Okay, but with our Move Guided, we only need 3 clicks. I'm going to play the video, and I want you all to watch intently because it's going to be fast and furious. And then you tell me what's going on. Okay, we are done in 3 clicks by using our productivity tools. Our productivity tools are a set of AI and machine learning enabled. Do you want to see again the video? Okay, I see some nodding. I'm going to play it again. PWG, native PWG open in BricsCAD as well. Let me play. I'm going to pause here for a while. What you're going to notice is our move guided. Once it copied, there is a reference line that it recognizes, hey, this wall is exactly the same entity as the previous wall. It snaps into it. Okay, you can actually invert it if you want. And what happened is this. With a release of our click, you notice that inside the wall is automatically healed. You do not need to trim, join everything, and the opening is automatically created. Whereas in the traditional CAD command, you still need, we calculated 27 clicks. So with this, an 8-second completion of tasks versus perhaps a 49-second completion of tasks. That's huge saving. That's efficiency for you. Okay, let me go on to the next slide. Now, as I mentioned, the title BIM without disruption. How can I omit sharing what is Octave BricsCAD BIM itself? I want you to take note that our BricsCAD BIM is not trying to replace your existing BIM authoring software. Okay, so if you have existing Revit, ArchiCAD of the world, most probably, okay, or if you are into the 3D experience from the sort, and you find that I'm not going to change my workflow, continue using it, okay? But what we are trying to solve here with our BricsCAD BIM is this. Okay, listen carefully, it's going to be thought-provoking. How do CAD users move into BIM without starting from zero? We are a DWG-based CAD software, okay? With, of course, AI tools to help you accelerate to get your 2D users into BIM readiness without disruption. It is very easy to learn. So, with this, I'm going to show you another video. That video is going to be I think, ×1 speed, because I only got 20 minutes to complete this before I hand over to my colleague. So I will explain along the way during that video itself. So what it means is, you receive a 2D drawing perhaps. You can start from scratch in creating your BIM elements in our BricsCAD BIM. But for this instance, what we did is, for example, you receive a 2D drawing and you want to convert that 2D drawing into a BIM model. Remember what I mentioned? Familiarity. This is familiarity. I'm going to show you. You're going to switch into the BIM environment. You're going to select the wall. What you're seeing here is tracing of the wall. It automatically detects the width of the wall. And you can actually join them together with the clip. We are creating a slab immediately. And we are doing the columns. Auto-detecting the columns even in irregular shape. I'm going to pause here. And once we rotate them, you will see, hey, it is a 3D model. Alright? It is as simple as tracing and extruding and detection. Okay, what the good things, the fantastic things is going to come. I'm creating walls, internal walls right now. Placing my doors, putting my windows which are parametric. You say, hey, I forgot, I need to recreate BIMs there. Immediately you can edit elements and reclassify them as a BIM. BIM as in BIM. Now, I'm going to pause here for a while. I'm going to show you this. BIMify, if you notice over there, is actually one of our AI tools that actually auto-classify your model into BIM elements, into spatial properties, okay, whereby you do not need to remodel in any steep learning curve, and you can actually, once it's done, you can actually key in your BIM properties. For example, if you have created a MEP duct ACMB and you want to put ProMat into it, right from the click, once you converted that particular ACMB into your BIM element, you can key in their name and maybe warranty if they have. So these are the things that is going to accelerate your BIM readiness without disrupting your workflow. If you notice, it is all about tracing. This particular video is to do 2D to BIM efficiently. Let's continue. Same floor plan, we propagate and we do a quick draw to replicate it. Floors are being defined, and then with that, I'm going to stop here. I'm going to let the video play. This is a government requirement from Singapore. What we did is actually the digital Conan X submission, whereby we actually developed with Singapore for the authority to be set for approval itself. So I'm just going to fast forward and I'm just going to move to the next one. Okay, these are the unique workflows that we have. Again, in BricsCAD philosophy, we do not need multiple tools and different workflows. Ours is pay what you need in terms of the licensing. During the technical demo, my colleague Claire will show you. Okay, one platform from 2D drafting to 3D to BIM. Okay, no translation. Everything is DWG, and we believe and we practice OpenBIM. When we want to collaborate our BIM model with other BIM authoring software, we export it to IFC, IFC4. We are in the process of getting officially certified for the infrastructure IFC right now. So with IFC model, you all know what is IFC, I believe. So with IFC model, you can actually briefly collaborate with a lot of other BIM authoring software. So interestingly, these slides will show you the additions that we have. So BricsCAD Lite is the alternative of your AutoCAD LT. Okay, what makes us different is our productivity tools. Okay, and of course we have a full LIPS integration whereby we give you the engine within our environment to edit or to program the whole LIPS. Full engine. And of course, in BricsCAD Pro is the vanilla replacement of AutoCAD. What makes our Pro different? Again, productivity tools are inside. We have point clouds integration. You do not need to have a third-party point cloud integration software. Like for example, in Autodesk, you need a ReCAD or ReCAD Pro to integrate the point clouds to start modeling. You can actually integrate the point clouds into our Pro directly. Okay, remember, we are optimized and we work very closely with Expert. We can handle more than 1 billion point clouds. Very good for A&A, very good for A&A projects as well. And of course, within that, we have our surveying tool sets. If you work with GIS, landfill, yes, you do not need a civil 3D. Unless you are doing advanced workflow that needs civil 3D. If not, the Pro is more than sufficient to cover your needs. And of course, we have BricsCAD BIM. BIM at the speed of CAD. If you are a 2D users, for you to embark and get ready for BIM, it's as easy as 2, 3. Okay? Again, in our BIM, in all our additions, there is the productivity tools. If you are embarking and get the license for BIM, the pro functionalities will be there, and of course the light functionality will be there. If you embark, okay Kelvin, I just want pro, your full version of pro functionalities is there, plus the 2D element will be there. So this is what we call one platform, connected workflow. Learn and progress at your own time. Buy the key or upgrade the key at your own time when you are ready. Start small, scale when you need. Again, this particular slide is to show the one platform connected workflow, especially for BricsCAD, from 2D to 3D to BIM. We are on DWG. It is not on other proprietary software. I have questions that ask me, Kelvin, can you open RVT file? RVT is a proprietary file format for Revit. My answer is yes. We not only yes, but we can open native RVT file. But there's always a but, right? In everything in life. We can only open one version back. And the reason is, it's a proprietary software of Autodesk. We need to catch up. I would always advise that I would rather you receive and export IFC form, which is a universal OpenBIM file format, to prevent any data degradation. Okay? You try exporting IFC from Revit, it is a hassle. They are now trying to position their own OpenBIM standard, which is, well, that's what it is. Okay, last but not the least, the key takeaway that I want you to take is this. Keep what works. Okay, add what matters to you. Remove what slows you down. Okay, if there's only one thing to remember from my whole entire presentation is you do not need to choose between CAD and BIM. Okay, you can actually evolve from your existing CAD into BIM at your own pace with BricsCAD. That's why my title of this slide is BIM without disruption. Again, everybody has a QR code, so do we. If you want to, you can actually scan BricsCAD for Architects, and you will bring it to our website. Okay, and then from there you can start surfing and getting a lot of more information, especially BIM as well. And then if you want personal one-to-one consultation, and I'm more than happy to discuss with you and offer you a different perspective of the workflow, especially if you want to get BIM ready. We are here to support you. Scan that particular update QR code and fill up some of the stuff, and we will contact you when the time is right. Bear in mind, if you wish not to, just let us know. We will not contact you. This is all GDPR. We are a European company, and we believe and respect the position itself. So take a moment, 15 minutes.
Chairman of the Pan Northern Chapter Architect this one. I'm not making it. And the Chairman of the Northern Chapter CPD Committee Architect, my old friend, Dr. Brett. Appreciate the Pan Northern Chapter invitation today for sharing and my team sharing. I'm not that far from the end, even though we are based in Singapore. I know Architect since my university day, and finally we reconnected maybe 3 years ago. There was a surprise reconnections. But those days we were in the same university but different years. But we all kind of exposed to similar things. And I had a good time in university, and I must say the university those days has shaped me in a certain way, and very useful and very ready. When I say I'm not that far from Penang because I'm born in Malaysia, I'm a Slovakian, grew up in Sarawak, studied in KL for a while, studied in Australia. Then my career is in Singapore for the last 30 years. And I only started to actively involved in Malaysia about 6-7 years ago. Actually, the Penang connection was I used to stay with Penang landlord, so I understand Penang's Hokkien a little bit different than others Hokkien. I get connected with the Penang people also because of the AI. I first heard about AI when I was in university, and then I was with the Penang boy at that time. His name by the name is Samuel. If you know him somewhere, you need to find out. He was a computer science teacher, and back in 1990s, every meal was talking to me about AI. It's coming. It's from Penang, not from anywhere. And he was studying this. They were doing a lot of high-level AI in those days. And he was the one who scared me about AI. I heard so much about AI is coming. AI can do this, can do that. 30 over years ago, okay, more than 25 years ago. And that's where I get immunity to actually about AI. So if today you heard about AI is coming, you probably will be, first of all, you try to turn your head about what is that all about, and what is it to do with me, how does it impact me. I think the usual question you'll be asking yourself, what's my role in the future, in the AI era? So, what do I do to change all these questions? So I would say, I'm not going to entirely talking about the AI that we leave it to my colleagues to speak, but I'm just a practicing architect like any of you guys, and we all facing the same change of the industry, change of the environment, change of the tools. That's how do we respond to it? And maybe I responded a little bit different than you, and which my sharing is that everyone is able to do that. And that's my today's topic. And how do I pass this? I think the first part I would do it. So this is kind of a group of the company. So we are an architects. Currently several companies. I want to just share about not so much about this. The companies in Singapore based, our team support. There's a lot of building. But the journey began when I came to Singapore and worked. And I joined the Singapore company's second day of life in Singapore, and I chose a company that the couple offered. I chose a company that's smaller size. So the idea was at that time about 6-7 years, very young company. But the founder who started this at 20 years older than I, he started this quite late, so to speak. But I joined the company was just a small setup, about 10 people. And I became partners in the company about 5 years later. And eventually, another 5 years later, which is 20 years ago, I started to run after 5 years of management. At that time, the company is still about 10 to 15 people. And we decided to grow the company because if we don't grow, don't change. We are just another architect, another kids in the market, right? Doing anything. So we decided 20 years ago that we need to be clear who we are, what can we offer in the market. So we decided to specialize some of the aspect of works, some of the area we want to learn to be good. And especially those areas that people doesn't want to learn, or architects doesn't want to touch too much. So one of which we decided to be good in industrial buildings. So in Singapore, as you know, there are many industries, and industry is important. Industry is the one that keeps Singapore alive in a small country. That's how you create jobs. So government in Singapore will never give up industry, creation of jobs, and that also given the investment as well. So industry is one market as well, focus onto it. The other part, we also focusing a lot of institutions. Institutions can mean training, educations. Also, the government is very focused on this. They will never cut expenses on all this because they want to train people, they want to educate people to maintain the quality workforce for many, many industries. So that's another area. Another third area we're focusing a lot will be on the military. So again, Singapore government spend a lot of money on defense. So we focus on defense. We've been doing defense for the last 25 years. Also defense from Navy, Army to Air Forces. So these are the areas that we start with. Even though we are any kind of job, residential, commercial, but the focus is to be good in those areas so that we can serve our customers better. So the journey began from there, and we start to work on semiconductor. There's an opportunity came, and one industry lead to another industry. So that's how I think it's important as architects, what are we committing ourselves to in the skill set? Are we valued by skill, or are we valued by our PR skill? I think I would rather be valued by our skill as the architects. I think that's the part that we decided to be good in something. And over the 20 years, we have built ourselves 10 years ago, probably, we were the largest architects doing all the industries. And then we do a lot of military, we do a lot of other institutional training as well. I think that allowed us to have a basis, and eventually we're able to have the ability to do more things as well. And today we are in our projects are in all these countries, and continue to expand because of our skill set, because of our commitment as well. And a lot of time it's not we are there, we're actually invited by the customer, or we were invited by partners to be in those countries. And this is our, I'm going to go a little bit faster, this is our Singapore team, this is our Malaysia team, not all. This is our offices in Philippines, in Australia, in China, Shanghai. We are about 250 and 260 people at the moment. So our expertise, as I mentioned to you, from 20 years ago, has built out to more than 20 over typology, but within the industry area, we are doing more than 15 types of industry. And that a little bit unique is because Singapore is small. Every 5 years, you can see different industry come in, some industry move out. So we move one to another, and you deal with the customer from MNC to the local big enterprise, government, lean company to the local SME as well. So that kind of a wide range of the customer. But today, the project involving is probably 50% of industry. We still do have 50% of wide area of the after typology as well. Let's just quickly sharing some of these consolidated work like semiconductors in different places. This is chemical, biopharma related unit of buildings, industry. This is infrastructure involved in port, wastewater treatment plant, and so on. More infra related. This is more related to aviation, automotive kind of works. This is related to agri-tech, food technology, and processing storages. we do large-scale planning, master plan, and also involved in sustainability, a lot of timber building as well. These are more commercial and multi-tenanted building. Other typology, high-rises or residential, these are once a while. And this is military related. These are a lot more, but this is just allowed to be shown because it's available on the internet. Institutional could be school, primary school to university, different types of institutions. The other thing that after we went to that stage is we do a lot of collaboration. So in our current collaborations, we do collaborate with companies in Japan, for example. So the collaboration with one of the company in Japan, Plantian Architects, Taiwan's architects, Australian engineers, allow us to work very closely to expand our shared resources and our shared expertise in that region. Together, we're actually now covering 20 over cities upwards. From our own 7 locations, expanded to the rest of the networks about 20 over places. These are our signing in Singapore, with the Japanese as well with the Australian. And with the Australian company like TDW, they are structural engineering, but they are very good in a few things. Digital is one area very good into it, and the other things that good in very good in timber, engineering wood building. So we have a collaborative plans to develop R&D to push beyond the boundary of those. How do we from the design, planning design, technical design, all the way to the engineering to make it a seamless kind of idea integrated to the deliveries. Some of the content is quite technical and how we do this. And the other collaboration is we actually also have a collaboration with institutions like university in Singapore or polytechnics in Singapore. They are regular partners. Either we invited to speak in their events or they do come to our office to interact, to learn from us how do we use technology in our works. And it could be from students all the way to the professionals. And this is the local government enterprise and authorities as well. They are often inviting us to participate in their events. Because of the technology, we actually spin off a company doing technologies to support the industry, how to transform the industry by sharing our own experience. And this is a military project and where they using our so from BIM all the way to the VR platform to other digital things. We are supporting them all throughout the jobs. Some other ministers and prime minister visit to us to see how the industry is able to move beyond. Not just local government, in overseas, like Malaysia governments, even state government, we also have opportunity to work with. This is where in Sarawak Roadmax Summit, we were our master plan plus our digital very important things that we work with the state government. Even Penang, you're familiar with so PDC, they also there to support, also to showcase our work technology. In other, I would say, industry engagement is through the exhibition, either by invitation or by exhibition. So PEN, we were in KL before. This is in Singapore. And this is in the architects is in KL. Also in Chongqing, events in the Singapore government. In the Azerbaijan, the Asian Development Bank invitation, we were in the Baku of them as well. Other collaboration is on the technology, and we had this Digi Alpha that we work with the Singapore Digital Economy team. Just like Malaysia, the MPAC is similar. Together we launched projects to help the industry. This is one example to help architects, help contractors to transform and harness that technology. And these are some very detailed program trainings throughout the years of the training. And also beyond that, we organize events. So we organize events such as the Immersive Architecture Asia. This immersive architecture was started by European many years ago. We became one of the pioneer partners with them. Eventually, we organized this in Singapore back in 2019 until today. Not every year, it was disrupted by COVID, but every 2-3 years it will be event. This was organized in 2019. Globally, many people will turn out to understand how do we share the use of technology in our industries. These are some of the events. Okay. We also had a future we call it IT Academy. This is the academy platform that we have to help our staff to use this as a learning, also sharing platform that will allow us to all learn and impacting the industry together. So I think all in all, just to share this, our journey and my journey as an architect from the Malaysian to become an architect, go beyond borders, and from the architects into a technologist. I think for the technologies, we are moving towards AI-ready future. I think these are the journey that we are going through. And I think my sharing with you is that we always maintain collaborative, also collaborating in many fronts. And also, we will always be curious about how we can be solution providers in all the works. And the next thing is to really be AI generative. Okay. I'll just going to pass on to Gerard, who's going to continue the part 2 presentation. We're going to just show you a video before Gerard starts.
So I'm Gerard. I'll tell you a bit more about how we apply technology, different kinds of technologies, VR, AR, computational design in our actual work as architects. So I think how it started is we were looking to go back to this idea of architects being the master builders, where we would have agency within the different areas of the construction project, but now as a digital architect through more high-tech means as well. So a lot of what we looked at was developing the tech, but also the integration of tech into existing workflows. So besides just the software, the hardware development which we were looking at, we looked a lot at process, application, how does this come into a design workflow, how does this come into a construction coordination workflow, how do we bring all these implementations to site, some of the issues that we looked at in terms of implementation. So when we started as well, we considered, what would the skilled architect, digital architect be? What kind of skill set would we need? So we knew that it's not going to be a completely different person. We still need the traditional skill sets, people who are familiar with construction, people who are familiar with design, but we need to equip them with more modern digital skill sets. So things like virtual design and construction, being able to review BIM models and things like that. So in our implementation, we also look at, how do we actually get our current staff who are familiar with construction, experienced with design, up to speed with the digital age. So another area we look a lot into is, besides the people, was the process. So this is, I think, quite a traditional process, quite a typical process for construction, where we start with a project brief, good concept, we start building BIM models, go to construction, and then post-construction. So here, it's a very linear process, and we also highlight, at each stage, what kind of tools, what kind of technology we use. So we really envision this to look something like that, where here you can see we do start at the same place where we have project information, we start site information, we have the client's brief. We start building on that, preliminary models, we do some visualization, we get inputs from other consultants, we go through coordination, revise the design, and eventually we end up with this chunk of data called the BIM model. So the way we see this BIM model is basically a repository of all the project information. So what's the design, what's the layout, what kind of takeoff are you going to do? So rather than split this information into, there's this set of drawings, there's this set of Excel sheets or whatever, we consolidate all into one database and we make it single source of truth, so that any data we get off, we always know is the latest and most accurate. So what we do from here is we will leverage this BIM model. We will start to extract and schedule this data. So things like for buildability score, for whatever scheduling we need, we do all our authority submission based off of this BIM model as well. So there is not one authority set in CAD that we maintain together with 3D model. And from here, this BIM model will also produce standard drawings for construction. So all based on the same source. So whatever we submitted to the authorities is exactly the same set that we use for tender as well. So here, then we get into physical construction, defects liability, and eventually we archive the project. So I think some of the things that you'll see here that's different from a very linear process is, in the process, we use VR in quite a few places. So usually the question is, where do you use VR in a project? Where is it the best to use it? So we do use it in many different stages. So we can use it in the early stages to get a sense of the scale, to see how it looks like on site, to check out sight lines and all that, all the way to nearing the end of the project, where we are looking at maybe fit and finish, certain terminations within the project, and a more look and feel kind of experience as well. So other areas you see would be parametric or computational design, which I'll show you some examples, but we also use in various stages. At early stage, where we're doing processes like generative design, to certain automation efficiency, as well as production kind of applications. Another one would be CDE, so common data environment, where we try to make sure that everyone is communicating on the same platform. So rather than you have to send a lot of information through emails, through WhatsApp messages, We make sure that every stakeholder in the project has access to a common data environment and are able to access the information that they need. Okay, so about our VR solution. So we developed our own in-house VR solution called BIM Matrix. So why we did this is we realized that, okay, all the features we need, the kind of application we want, nobody from outside the industry is going to develop it for us. So we had vendors, we used to work with software developers outside the industry who came from the software development background or engineering background, where they would say, okay, gaming background, where they say, okay, this is the kind of software that other industries use and we'll develop it this way, and the construction industry will use it this way as well. But it wasn't really applicable for what we wanted. So at some point we realized, okay, if we really want this solution, we're going to have to develop it on our own. So that's when we started developing it in-house. So how we develop BIM Matrix is also, our goal was for it to be an interface into the BIM information. So I think we've heard a lot about BIM, how great it is, there are these detailed models, what information is inside. One of our biggest problems with it was how accessible this information was. So we realized a lot of our own architects weren't able to access the BIM models as well. So the people making the submissions might not have seen the models before it goes to the authority side. Certain stakeholders, especially the clients in the projects, the developers, they have no access to the BIM model. So even if we hand it over to them, they don't know how to open it, they don't know how to manipulate the model, get the data they want. So VR was a very natural solution for this, where we can put on the headset, we can see exactly what's in the model, and we know what will be built before we actually go to the site. So we also considered, okay, what would the utility be for VR in construction, whether it's just a gimmick or we could actually solve some issues within the construction process. So a big part of it would be communication and coordination in construction. So we developed it to extract the BIM data, view it, and as well coordinate it so that we could pick up issues and actually resolve them. So rather than just being an interesting gimmicky tool where we put it on, look at the model, walk through it, we actually made sure that we could do a virtual site walk, pick up the issues, and rectify it so that when we go to physical construction, they would no longer be there. So some of the other features we developed would be things like non-local communication and coordination. So this helped us a lot when we had projects in different geographical locations. So for example, when we had lab research here in Penang, when the clients were over in the US, when we were in Singapore, and we needed to communicate design ideas, design content to all the stakeholders, we were able to set up a virtual environment so that instead of doing Zoom meetings, looking at drawings on the screen, everyone trying to figure out what everyone's talking about, we could meet directly inside the project in the latest BIM information and quickly resolve any issues there. So we developed multiple modes. So we were not so concerned about developing a VR tool. We really wanted it to have utility as a coordination tool. So whether you had a VR headset or not, or you're just accessing it on a laptop somewhere, you have the same kind of features. So issue management was also a big thing. So we wanted to make sure that we could track the issues, see what was updated, what was discussed, and then be able to rectify it as well. So another big part of what we developed was the workflow and process to use it. So we knew that the solution wasn't going to be, just have the software, the hardware, you buy this and you'll be able to implement on the project. So we developed it as part of virtual design and construction process. So how would you coordinate it? When will you do the coordination meetings? Who would need to attend? How will you fit that into your existing process and meetings? Was something that we looked at as well. So in a simple internal process, extracting the information from the BIM model, going into VR and updating it, to a more detailed workflow that more reflects the actual construction workflow with the federated models. There are multiple viewing sessions as well, so things like coordinating between HQ and site, between design and the actually physical build, where we have specialist consultants and how we do design reviews with the clients as well, and how everything will be coordinated. So this is a bit of just illustrating how we can have different hardware setups to provide for different physical locations as well. Okay, so that's a quick overview for VR. So for computational design, I think what we're really looking at is, okay, how do we get towards very data-driven, evidence-based kind of design? So rather than doing all the calculations, trying to figure out how it works after the fact, after doing design, we integrated it into the design process. Where here you can see certain images, okay, what happens when we shift this floor plate, what happens to the GFA, what happens to the RAM, the headroom of the RAM, and does everything still fit? Are we still within the boundary? Do we need to reconsider the setback or whatever it is? All the way down to facade fabrication, how we look at altering the designs, making sure that we can fabricate it on site after that as well. So this would be a bit on design for manufacturing and assembly, where we look at a typical design process, how we get to fabrication and assembly on site, and how we could optimize that by using technology to address all the concerns from design intent to structural concerns from the engineer, cost, time, safety issues from the contractor, and all the fabrication requirements from the manufacturer as well. So we essentially develop scripts to automate all this to make sure that when we design, we go directly to manufacturing and eventually installation on site. So AI, I think now everyone's aware of AI thanks to companies like OpenAI. Everyone's used it in some capacity, whether it's ChatGPT, Gemini, something to give you results on writing copy or doing research. So everyone's aware of the kind of capabilities that AI has, and I think it's only going to grow. But for us, of course, it's how is AI relevant to us in construction? What would be the kind of applications we can use it for? So then on our end, we've identified two main applications. So one that you see here is really AI for production, for generation of image, videos, content. So this is my colleague Celeste will talk a bit more about later. But I think what's interesting for us as well is looking at how AI can assist us as architects. How do we develop agents that are able to develop design? So rather than just we are talking to it and it can give us some textual response, how do we get it to be contextual, to understand things like building code, to understand design limitations, and to not just respond to us in text, but to actually give us reference designs that we are confident in. That okay, this is a massing that will work for your project, for your brief, that fulfills your GFA requirement, it fulfills all your bylaws, and it will be a good starting point, and we can start to work with the AI co-pilot to say, okay, what else needs to be done, how do we change it for this specific project. So this is something that's already in progress. We are actually actively developing a solution. So, okay, maybe from here, I'll just do a quick demo of the kind of topics that I've covered so we can get a bit of better understanding. Okay, so I'll just go through a quick overview of the kind of tools and software that we develop. So what you see here is actually Rhino and Grasshopper. So what you see here on this website, this is just a 3D model. Alright, so Rhino is kind of like an advanced SketchUp, you do 3D modeling with it. So what you see here is a topography surface. So this one we've got from the actual survey, but we have several ways of getting this. We could fly a drone to get a quick update. We could use databases which the government has, or the most accurate way to be actually do an on-ground survey. So then here what we see, this is actually the computational script. So it's the same as programming, textual programming, where you see lines and lines of code. The only thing is in a visual interface. So it's the same kind of logic, but with a node-based kind of interface rather than text. So what we see here, now that this is reading 0, we can see all these areas that's highlighting on site in blue, right? It's actually all the areas on site that's perfectly flat. So as we increase this, you can can see that it starts to highlight more and more areas on site. So it's telling me now that, okay, all these areas that are highlighted on site are 18 degrees or less slope from the horizontal. And we are telling it, okay, can you just add them up and give us a total area that all this is covering? So this is a very quick way that we can look at a data-driven kind of analysis. We know that it's very accurate, it's correct. Whether it's to comply with code that says, okay, you cannot build on any land that is steeper than this angle, or we want to optimize and say, okay, this is the area that we want to build on first so that we can minimize cut and fill operations, minimize retaining wall works and that kind of stuff. Okay, another application which we use the tools for are automation and efficiency. I think every time we see a repetitive task that we do over and over again for every project, we start to see an opportunity of how can we start to develop a script, develop some intelligence that can help us so we don't do this task over and over again. So one of those tasks is car park lots. So car park lots for every project, and there's actually a very fixed way to generate it. We know the size of the lot, what happens when it's a parallel lot, a perpendicular lot, what's the size of the driveway, one-way, two-way, angle lots, all that kind of stuff. It's all detailed in the handbook, but for us to go and execute it, it's opening the CAD files, making one car park lot size rectangle and manually placing it one by one just to figure out, okay, for this plot, how many lots can we get out of it. So what we did is we developed a script to do that, where we say, okay, this is the lot we're looking at, you plug it in, and can you just tell us how many lots we can get out of it. So, a very simple automation, but can actually save us a lot of time as well. And we know, okay, there's more than one way to put car parks in the lot, right? We can change certain parameters as well, where we can say, okay, what if we shift the parameter lots to parallel parking? What happens if we try and squeeze the lots together to see if we can get more lots? Or what if we say, okay, actually our boundary is slightly flexible. What happens if we made it slightly bigger or smaller? Can we maybe try and squeeze out one more lot in this case? So we can try and adjust our boundary. And we can see actually with a small change we could get, 6, 7 more lots out of it. So even a simple operation like this, to do it manually, we're taking half a day, a full day, and we're not even sure of the results. So here is something that lets us automate it and be confident about the result very quickly as well. Okay, I think another application would be ramps. So whether they are pedestrian ramp, car ramp, heavy vehicles, actually all the same thing. It's just what's the allowable gradient, what's the width, what's the turning radius. Otherwise, they are all just slope incline, right? So typically, we are always looking at the headroom issue after that. So when we go up in one dimension, quite easy to calculate. We know rise over run. When we go up in 2 dimensions, slightly more complex. When we start to add in gradients on thirds and all that, it becomes quite complex, easy to make mistakes, and when we make those mistakes, it can be very critical to the project, because once we shift the ramp footprint, the whole building footprint changes, and then usually we have to replan everything. So we are concerned that we want to get this right from the start as well. So you can see what we have here is we can actually adjust this ramp to have different entrance positions, change the size of the ramp, the steepness, whether it's multi-floor, less, first floor offset, double, triple volume kind of. So we can manually adjust all this, but here we want to make the computer do a bit more, to give it a bit of intelligence. So we can run it through a solver. So you can think of this as actually a basic version of AI, where instead of me manipulating it, I can tell the computer, okay, why don't you go and figure out the solution for me? And now I've given it certain parameters to work towards, certain optimization parameters. I'm saying, okay, minimize the CFA because this is just a functional part of the building, so why make it bigger than necessary, right? Why make excess CFA? But at the same time, I'm saying, okay, don't make the smallest, narrowest ramp because then it's very difficult to drive up. So take my consideration, weigh in this ratio and give me certain optimized results. At the same time, also figure out this void in the middle, right? Can we make it as square as possible? So don't make it very long and narrow so that we can put more M&E equipment within that void. So that's our design strategy. We convert it into AI and say, okay, now solve for us. And actually you can see this is a very simple problem for the computer. Something that would really take a human days and days to solve this, within a minute is going to solve it so early. So here is where we can even, we don't really go for coffee now. It's already done already. And we will look at, okay, all the thousands of outputs that it gives us and say, okay, out of the top 5, top 10, which one is the most ideal? Maybe we take this one, we tweak it a bit, and it's the most in line with what we want to do. Okay, so that was a bit about automation efficiency. But I think, okay, where the tools get very interesting is how can these tools help us design? So what we see in this example is really a more design based. So this is the township planning, where we have all the design parameters. Okay, what's the different unit mix that we want? What kind of different typologies do we want? How are we going to separate the program on site? What kind of design strategies do we want? We want terracing design, how do you optimize views? So all very typical design intent when we start a site. But what we did is we convert all of that into computer code. So now what this is able to do is based on all our requirements, what we wanted to do is say, okay, give us a design that works, that fulfills all these criteria, that has this number of blocks, this kind of unit mix, your kind of block typology, and yeah. Basically now this is a design that works, fulfills all that criteria. And if you say, okay, can we just look at something else, give us a few options to look at, all we have to do is regenerate again, and then it will go through all the criteria, come up with a slightly different scheme and says, okay, this is something else that also works, that fulfills all your criteria, but it's different variations. So we can really just keep going. Typically this is where we evaluate it. We start looking and saying, okay, is this what we want? Or we can use more empirical methods to evaluate it. Okay, how close are all these blocks to the nearest MRT station? What are the number of units that have a good view? And all this kind of thing, we can say, okay, these are what we're looking at and give us more results that look like this. What else we can do as well is we can change the input parameters. So, client change their mind, or we just want to look at something else a bit different. So we can say, okay, our strategy now is to create more blocks, but shorter blocks, so that the blocks behind have a better view out to this waterfront area. So actually all we do here would be just increase that. So we can say more blocks. We can also say something like this. Okay, this green open area, maybe you don't want it smack in the middle of site, maybe you want it to be somewhere at the side so you can connect to a park connector or something like that. But of course now the problem is that all the blocks are sitting on top of it. So once we have that, instead of the typical process of, okay, now we're going to pre-calculate everything, it's going to take at least another 2 weeks and all that, we can quickly regenerate and say, okay, take our new parameters into consideration of that works. So you can see really instantly it's said, okay, new parameters, more blocks, shorter, we shifted the buildings out of the green area, and this is something else that works as well. So this is great from the quantitative aspects of things. All the numbers work for this project, but from the qualitative side, this is still not exactly what we want. So if you want to sell a concept, an idea to a developer, this is going to be a premium result kind of thing, this image isn't going to cut it. But the problem is if you go and do rendering, production, then you have to model everything out, it's going to take weeks and weeks, and just for a proposal kind of thing. So what we can do here is we can put another layer of AI over this. Right? When we say, okay, this is our layout of the blocks, we know all the numbers are correct, the GFA is correct, and give us image that we can use to sell this concept. So we give it a prompt, we say, okay, this is a waterfront development, whether it be sustainable, futuristic, and all these kind of things. And you can see immediately that it gives us some feedback. So, okay, not perfect, but it's gotten all the key parameters right, the number of blocks or orientations relative to each other. So, as opposed to, if we just use AI and we say, okay, we are giving you this prompt and then generate something for us. So I think this is probably more familiar with just give it words, text, and say, okay, create something. So you can see here this is maybe an interesting image, but not so relevant because how do we know what's in this? We don't have much control over it. So one of the key points here about AI, I think, is how we use it would be how much control we actually have over the AI. Can we get it to do what we want rather than what the AI wants? So rather than we designing for the AI, we get the AI to work for us within our design, within our parameters as well. So I think this is just a quick overview of all the different technologies we have. So specifically for this visualization AI, I'll let my colleague Celeste tell you more about it as well.
Good afternoon, everybody. It's almost lunchtime, so I'll try as quick as possible. My name is Celeste. I'm also part of IT Architects in Singapore. I work as a creative director for the company. So as Garrett mentioned, my focus for today would be more on AI usage in terms of visualization. And in our case, what I think is propagating is really telling our architectural stories with the use of, with an extensive use of. So as an example, I'll just play a very quick video. We went through this AI journey a year ago when we started to realize that AI tools in the market have already somewhat matured and good enough for us to leverage on. So this would be a video of what we have been experimenting so far. Okay, so that was just a quick one. It's really one of our earlier works. When we did some research at the time, there was no advanced version of Gemini and Nano Banana yet. But we were aware that you could be able to make use of a certain prompt which is more meaningful, like a sketch or a 3D model. After considering making all your design decisions, and if you want a quick visual, then the second image on the screen is actually AI generated. So at this time, we were still using ChatGPT. But of course, the tools have already become more sophisticated. And so we also ventured into, after Gerard's mention of computational design, we could also try to incorporate the visualization visualization hand in hand with the computational. So even here, because I'm not really adept at computational or even programming, but with the aid of AI, I was able to create like a very basic script and then to be able to show it in real time as we modify the sliders. Then you could see that you could already see what the proposal is looking, if it's fully wrapped. So yeah, some early use cases that we used in IDE. In the beginning, it was really like providing a sketch and then coming up with a certain design which we curate. So what you see on the screen are just like basic examples. There's one where we had a proposal for a boardwalk design in Singapore, and then for a quick visual, we were able to come up with the images below. And then the one in the middle is a house, one of the houses that we're designing. And the client just wanted to see like a very quick iteration of what it would look like with certain materials. And then it's the same house on the right, which is the interior. So just to make like really quick design evaluations is very useful with AI, because otherwise, like my colleague Gerard mentioned, this would take hours, days to just modify design. So in this example, it's really, right now, it's designed as a mini garden in the middle. So what if we transformed it into a Zen garden? So in a matter of seconds, minutes, with the right prompting, then we would get this kind of result easily. And then here, this is like a very good, one of our really good examples of how we maximize AI. We were invited for this one project. They only gave us 1 day to come up with the proposal. So the one on the left, which is actually the 3D model, the base 3D model that we were able to come up with, addressing all the basic requirements of the project, building the base blocks and massing of the project. But then the next step is how to translate this into something more presentable. And so with the aid of AI and a bit of prompting, then we were able to come up with some of these iterations, which in turn we reiterate over and over until it addresses what we believe as designers and architects is the right approach. And we came up with this. So in a matter of 1 day, we were able to do all these. It was very fortunate for us because we did win the project eventually, although the design doesn't look like this. But from here, I think you could see the value of making use of all these AI tools currently, because it will really speed up your production process. Yeah, this is another example where, again, it's a very quick proposal. This one is in Sarawak, and then we had like a base sketch here, and then to come up with a very quick visual, also with the aid of AI. This is what the sort of quality that we need. Yeah, just more examples. So it's really just a mix of having your basic design parameters, your basic 3D model with some sketches. So I keep mentioning sketches a lot, because in our experience, the sketch, the hand sketch, coupled with the 3D model is a very powerful prompting, because AI does not necessarily understand what you're trying to design unless you input all these image prompts. So further examples, this is just an extension of that boardwalk design that we have been doing. Eventually we got the project also. And then as we do the production during the design phase, so when we are iterating it, then with the aid of AI, I think we're able to really maximize the design process. Yeah, and this is another example. So it's an ongoing project. It's one of the towers we're designing. So to be able to come up with different iterations based on a singular massing 3D model already enables us to review and explore different types of styles. This one is really just a list of the current tools that we're using. So a lot of it is really Gemini, a bit of ChatGPT, of course. We use a bit of Claude as well. There's Midjourney, and then some animation tools such as Clean AI and then VO3. And the rest is really just like you're supporting AI tools, including your Adobe softwares. For those who would be dabbling with AI, you would understand why it is so important to have all these very quick editing softwares, because AI is not exactly that. AI can generate anything, but there's a big but. You still need to modify it. It's not perfect at this stage. So, like the human input is still very much important. Yeah, okay, this is really just, it's a storyboard for an old video that we did in 2008. And at the time, I had a team of like 10 people, and 10 people working for a month with about approximately 15 computers. We were doing it in everything in 3D, we were animating everything manually, we had to render it for each. So with that amount of resources, more than 15 years ago, then I thought to myself, what if I like took the current AI tools and did it by myself during my free time? What could I possibly come up with? So just like trying to test the limits of what AI currently is capable of. So the result is this one. And this was done, just to take note, this was done in about maybe about 2 or 3 weeks spare time with no, just purely